Good day! Today we are going to study number sequences, and this is the first lesson under the first quarter of grade 10 mathematics. In this specific lesson, we will study the concept of generating patterns. That is the first objective. The second objective is that we will be able to illustrate an arithmetic sequence. And the third objective is we'll be able to determine arithmetic means and term of an arithmetic sequence and the sum of the terms of a given arithmetic sequence. Okay, so let's move on to the first objective, which is generating patterns. Okay, so let's have first the review session. So in this review session, we'll be able to answer the questions considering the pattern. Okay, for the first question, here we got the pattern. Square followed by one triangle, another square followed by two triangles, another square followed by three triangles, after that another square followed by four triangles. So obviously the pattern is that the number of triangles is gradually increasing after a square. So here, after the four triangles, what should be the next step? Yeah, that's correct. The next step is a square. Now, let's move on to the second question. The second pattern is that we got here 0 followed by 4 followed by 8 followed by 12 and followed by 16, and we have here an unknown number. Question is that, question number 1 for this second example, what is the next number? So considering the pattern, as what you observe, the pattern is obtained by adding 4 from the preceding number to get the succeeding number. So to get 8, definitely we'd be able, or you should add 4 to 4 to get 8, and you should add 4 from 8 to get 12, and therefore the next number after 16 is, you're correct, it should be 20. And as what you observe, 20 here is the sixth number. Let's answer the second question. What is the 10th number? Since 20 here is the sixth number, we know that the 7th number is 24 because the pattern is obtained by adding 4. And the 8th number is 28. And the 9th number is 32. And therefore, the 10th number is, you're correct, the 10th number is equal to 36. So as what you observe, the next or the set of shapes and the set of numbers in this activity are called sequences. Now, what are sequences? Or what is a sequence? So, a sequence is an ordered list of numbers or shape. Take note, they are ordered, or it follows, or they follows a pattern. Another definition is that a number sequence is a list of numbers having a first number, a second number, a third number, and so on. And these numbers are called terms, denoted by the symbol A sub n. Okay. Now, let's try to discuss finite and infinite sequences. Let's consider the first example, 10, 15, 20, 25, and 30, and the second example, 11, 22, 33, 44, and 55, followed by ellipses. Considering the first and second example, we can discuss the finite sequence. So, what is a finite sequence? So in the first example, 10, 15, 20, 25, and 30, this is what we call an example of finite sequence. Why? We are considering two considerations. The first consideration is that it is finite because it has a finite numbers of term. meaning we can count each term. However, if we're talking about infinite sequence, the second example is definitely an example of what we call infinite sequence. 11, 22, 33, 44, 44, 55, and an ellipsis. Since it has an ellipsis, it means that the number of terms is infinite, meaning we cannot count it. Why? We cannot count it because it has no last term. And that is actually the opposite of what we call finite sequence. A finite sequence has a last term, but an infinite sequence has no last term, and we cannot count its term. So that is the concept of finite sequence and infinite sequence. Again, if we're talking about finite sequence, it has a finite number of terms and it has a last term. However, if we're talking about infinite sequence, the number of terms is non-countable and it has no last term. Let's move on. Number sequence. Sequences are usually given by stating their general rule or end term a sub n. So, number sequences or number patterns can be represented by what we call general rule. To understand this better, let's try to consider the first example. So in this first example, we are tasked to identify the 5 terms of the sequence represented by this what we call general rule or end term. And the end term is represented by this equation. A sub n is equal to 3n plus 2. Now, in order for us to identify the first 5 terms, we need to understand that the first term is represented by a sub 1. The second term is represented by a sub 2. The third term is represented by a sub 3. And the fourth term, a sub 4. And last, the fifth term is represented by a sub 5. As what you observe for the first term, the value of n is 1. For the second term, the value of n is 2. For the third term, the value of n is 3, and so on and so forth. Now, let's try to compute the first term. In order for us to compute the first term, we know that the value of n here is equal to 1. So all you have to do is to substitute the value of n in the given general rule, which is 3n plus 2. So instead of writing n, we should write 1. So 3 times 1, that's 3, plus 2 equals 5. That is for the first term. For the second term, our n here is equal to 2. So equals, substitute 2 to the variable n, then 3 times 2, that's 6, plus 2, then it will give us 8. We can say that 8 is the second term. For the third term, we know that the variable of n here, the subscript of a is 3. So, substitute the value of n, 3, to the variable n. So, 3 times 3, that's 9, plus 2, then that is 11. For the fourth term, we get here a sub 4. Our value of n is equal to 4. So, we got 3, substitute the value of n, the variable n, and that's 4. 3 times 4, that's 12, plus 2, then it will give us 14. And definitely, for the last term, we got a sub 5. So here, our value of n is equal to 5. So 3, substitute the value of n5 to the variable n in the given rule, then basically we got 3 plus 5 plus 2, then that will give us 17. And from this, we can conclude, therefore, the first 5 terms of the sequence represented by the general rule or end term 3n plus 2 are 5, 8, 11, 14, and 17. Okay, so let's move on to the second example under number sequence. So in this example, we are tasked to identify all the indicated terms for the general rule a sub n equals 4n minus 2, following the condition that the value of n should be less than or equal to 6, but it should be greater than or equal to 2. So considering this example, we can generalize that we're talking about the second term, the third term, the fourth term, the fifth term, and the sixth term of this specific equation represented by a sub n equals 4n minus 2. So, just like the first example that we performed, in order for us to identify the second term, just simply substitute the value of our subscript n to the given rule 4n minus 2. So we have 4 times 2, that's 8, minus 2, it will give us 6. Therefore, the second term for this specific sequence is 6. For the third term, our value of n is 3. So 4 times the value of n, 3, that's 12, minus 2, that gives us an answer of 10. Therefore, our third term is equal to 10. For the fourth term, the value of n is equal to 4. So 4 times the value of n, 4, the 16, minus 2, it will give us 14. For the fifth term, we got here n which is equal to 5. So 4 multiply the variable to the value of the variable n, 5. That's 20 minus 2, that gives us 18. And for the sixth term, our n here is equal to 6. So 4 times 6, that gives us 24. Minus 2, then that is 22. So as what you observe, we have here the values 6, 10, 14, 18, and 22. From that, we can conclude now. Therefore, the terms of the sequence given the nth rule, a sub n equals 4n minus 2, following the condition that the value of n should be less than or equal to 6 but greater than or equal to 2, are 6, 10, 14, 18, and 22. I hope you learned a lot from this session, and please watch our next video about arithmetic sequences. Good day and thanks for watching.